Hello everyone, Suhail this side. Welcome back to my channel. So this would be the sixth video in the Kafka Zero to Hero series. So let's just quickly recap what we have done till now, and then we'll discuss what we are going to do in this sixth video, right? So in the last video we have discussed partitions and how important is the partition keys, right? And then we went ahead and we discussed the consumer groups, why consumer groups are required, what purpose they solve, right? Then we did demo, actually the practical demo, and we saw the problems when we start the consumer without consumer group, and then actually we solve all the problems by introducing the consumer group, right? So and then eventually we saw, okay, how we can scale Kafka, ensuring messages should process in order. We have seen by increasing the number of partitions, and we are ensuring that okay, these messages would be processed in order, and at the same time how we can scale the Kafka, right? Then we have discussed how important is to select the good partition key, because if our key is not selected properly, the partition key is not selected properly, right, so we can unnecessarily underutilized or overutilized the resources, right? Because for example, in the last video I mentioned, right, for example the date could be a partition key, but if we select the date as a partition key, so every time the hash value would be same for that particular date. If we are getting the date in the dd mm yy format, right, we are ignoring the time. If we are just considering the date, that would generate the same hash code and all the messages would eventually persist in the same partition, right? So that was the problem with the bad partition keys. So it is very important to select the good partition key, right? Now let's move forward, and what we would be discussing today, we would discussing partition rebalancing in detail. Then we will discuss the scaling scenarios. In the last video we have not covered the scaling scenarios much, but in this video this would be the in-depth video on the Kafka scaling. And from this video I am sure you will get at least 3 to 4 questions in interview for senior engineers as well as for the medium engineers, for example the engineers who have close to 3 to 4 years of experience. So this video is very important for all the engineers, and it would help you in the interview process. Now without wasting time, let's move forward, and firstly we'll discuss the partition rebalancing. I'm just opening up the Kafka console, right? So the same, I have just started up the Kafka server, right? For example, as I already shown you in the last video, we are not doing anything, just doing the Docker compose up, and our server is up and running. For example this, right? So what I have done here, I have just done the Docker compose up. The same way you have to do, right? Now your Kafka server is up and running. I'm just going directly to the screen where we can actually produce or consume the messages. In the last video we have created the order events topic. Let's see, because I have not deleted anything from the last video. So firstly let's see the topics, right? So the same topic is still present, the order events topic is present. Now what we'll do is we'll start consumer, and both consumers will start. We have, in the last video we have selected the consumer group as payment service. Let's do the same thing, right? So here what we are doing is Kafka console consumer, that is the command for starting the consumer, and bootstrap server, that is for connecting to the Kafka cluster. For which topic we are starting the consumer, this topic we have mentioned, and these are the general properties which we want to see. For example, if we use this property, so in this console we'll get to see the key also along with the message, right? And similarly the next part what we have done is we have mentioned the group, right? So the group I have mentioned here is payment service, right? Now let's start the producer as well, right? So in the left side window I'm starting the producer. First of all let's start the consumer. I have started the consumer. Now in the left side window, I'll be starting the producer. What is the command for that? It is very simple. The console producer.sh, the similar bootstrap server for connecting to the Kafka cluster, and for which topic we want to produce the message, for the order events topic, right? And these are the general properties, because we have created this topic with two partitions, right? If we don't use this property, then pass.key or key.separator, then what will do, Kafka will treat this message as a single string message. It will not treat it as a key value kind of pair, right? So for that we need to mention this property, so that Kafka can actually parse the key, and based on that it can decide, okay, in which partition it has to send the message, right? So this all we have discussed in the last class. Now let's start the producer. Right now, let's produce some of the messages as we have seen in the last class. For example, just for here, for example, this is the key. We have mentioned the key separator as colon, so 1 is the key, and the value is order 1. It could be a kind of JSON message in real life. For example, it would have order ID, order order name, the products, the items which are there in the order created DTM. So all these fields would be in a JSON message, but the partition key would be the kind of order ID or anything which you can decide, right? So the partition key, let's assume this is the order ID and this is the JSON, but for simplicity I'm just sending the simple string message, the order one, right? Because we just want to see whether in which partition or which consumer is receiving these messages, right? Now let's produce this message. We can see the message has been consumed by the consumer. Now this property print.key, right, we have mentioned here true. That is why we are getting the key as well, right? If we don't mention this property print.key is true, then we will just only get the message directly, right? Now let's produce one more message, order 2, right? So if you see, all the messages are consumed by the consumer, right? Now if I produce some more messages, order 4, then it is all right. So all the messages are being consumed. Now let's assume because of some auto scaling, suddenly the load has been increased on your application, right? And you started one more instance of this, for example, the payment service, right? Now you started one more instance, means you started one more consumer, right? So when you do that, let's start this. Now if you see the logs, right, if you see the logs, so when we did that, when we started the another consumer, what has happened, the reassignment has happened, that is the partition rebalancing has happened, because the topic which we have created, this topic is with the two partitions. Later I will describe that as well, that this topic is still the old one which we have created in the last video, and that is having the two partitions. So when we started the another consumer, this partition rebalancing has happened, right? And so what would happen in this case, since we have the two partitions, one partition would be assigned to consumer 1, right, and another partition would be assigned to consumer 2. Now let's produce few more messages and let's see where it goes, right? Now if you see, right, so fifth key with the key value pair is, like, for example, the key value 5 goes to the second instance. Now let's produce one more message, order 1, right, it goes to instance 1. Now let's produce few more message, order 2, right? Now you will say, okay, earlier the order 2 was going in this consumer, now the order 2 has been going to this consumer, right, the second instance. But if you have to maintain the ordering, it should go to the same consumer, right? But whenever you have to note this, whenever actually the partition rebalancing is happening, so at that point of time there is a chance that the messages would be for example, would be consumed by the other consumer as well, right? So that is why the messages are being given to the other consumer, right? Now let's produce few more messages, order 6, order 6, right? So second instance, order 7, right? So order 7 is going to this instance. Now from now onwards, if I send the key 7, it would always go to the instance 1. For example, now the key with value 6, key 6 is going to the instance 2, right? So if I send this message again with any value, right, so it would go to the instance 2 only. So once the partition rebalancing is happening or has happened, after then all the messages would go to the same consumer for which the partition has been assigned. Now let's close this consumer, right? Let's produce few more message. For example, now let's produce 1 order 1 or 7 order 7. Let's produce 1 order 1, right? Now you will see earlier 1 order 1 was where it was going to the instance 1, but now where it is going to the instance 2. Let's do the 7, right? Now again the instance the key 7 is going to the instance 2, right? So in short, the meaning is that whenever the one of the consumer is being down or another consumer is coming up, so if whenever any consumer joins or leaves the Kafka cluster, so Kafka partition rebalancing is happening, and the partitions get rebalanced and assigned to the consumers accordingly. For example, there were 2 partitions, so when we have 2 consumers, one partition was assigned to one consumer, the other partition was assigned to other consumer. So that is how the things has happened in the partition rebalancing. Now if we see the logs as well, you can see here every time whenever we are starting the new consumer or bringing down the consumer, the partition rebalancing is happening, right? So this was the demo. Now let's see more scaling scenarios. I have more points to discuss. So let's discuss about the consumer group scaling scenarios, because this is very important. So first case, right? Now let's assume this is the case what we have done. Now in our demo we have created the topic, the same topic, order event topic with the 2 partitions, but for simplicity you can assume in the production on in the real life scenario there could be 40 partitions, 100 partitions, there it could be any number, right? But usually I have seen partitions with the 100 in number as well, right? So in reality your topic can have any number of partitions, right? Now for simplicity, for visualization, we can assume this topic with the 3 partitions. For example, the blue color ones is the partitions, right? And this is the order event topic and these are the partitions. Now the case 1, for what is the what could be the cases, let's see that part, right? So for example, there is only one consumer, right? Now we have seen the demo as well, right? So if we have one consumer, what would happen in this case? So all the partitions would be assigned to single consumer, right? So that is the very simple case if we have only one consumer. Now let's see the other case. What could be the other case, right? So the other case could be that one more consumer joined due to auto scaling or any other reason. So now 2 consumers are there, right? Now what would happen in this case? No, but partitions are 3, right? Now what would happen in this case? Now 2 of the partitions could be assigned to one consumer, one of the partition could be assigned to another consumer, right? Now what would happen, that as I earlier mentioned, that when the new consumer joins or leaves, Kafka do the partition reassignment and will assign one of the partition to the new consumer joined, right? And the remaining 2 partitions keep assigned to the same consumer, right? So in this case, the 2 partitions which were earlier, what was happening, all the 3 partitions were assigned to one consumer. Now this time when the new consumer joins, right, now the 2 partitions keep assigned to the old consumer, but out of 3, 1 partition would be assigned to the new consumer, right? That we have already seen with the 2 partitions in the demo, right? Now what would be the other case? The other case could be that one more consumer joined, okay? No, in this case, so total 3 consumers, right? No, 1 2 3, three consumers are there and we have three partitions, right? Now what would happen in this case? Now again the new consumer has joined, again the partition rebalancing would happen. What would happen in this case? Again the now the partition would, one of the partition would be assigned to the new consumer, right? Now each partition, once this is done, now we have topic with three partitions and we have three consumers. So partitions is equal to the number of consumers. Now what would happen in this case? Each partition would be assigned to each consumer, right? So we have a fair distribution actually, right? Now this could be the third case. Now what would be the fourth case? What would be the fourth case? That, for example, suddenly your application load has been increased. No, right? Now what would you do? Okay, you start the, for example, you instantiate one more instance, right? Now let's assume you instantiate more instance. What would happen in that case? You instantiate one more consumer, in short, right? Now what would have happened? Four consumers are there, right? But partitions are still three, right? Partitions are still three. Now in this case what would happen? The other consumer, the fourth consumer, would keep sitting idle. It would not receive any messages, right? Because the three partitions are already been assigned to the three consumers, so there is no partition left over to assign to this consumer, right? And in this case, as I mentioned, the consumer, this consumer, right, this consumer would sit idle because there is no partition available to assign, right? And one thing to note, that we cannot assign one partition to different consumers. Why? If we do that, or if Kafka guys have done that part, right, then it would be kind of issue in the message ordering, right? Then we would fall into the message ordering issues, out of order issues, right? That I have already explained in the last video. For example, the withdraw and the deposit, right? Withdraw gets processed first and deposit processed later. So due to that, there could be a chance that the user, the stale data would be there, right? So in that case, that would be a problem, right? Withdraw cannot happen until unless the deposit is there, because user has firstly deposit the amount, then only he has requested for withdraw. But in the last video we have seen what problems can happen with the out of ordering. Withdraw message can be processed first and then the deposit can be processed, so due to which withdraw process can be rejected because there is no money in the user account to withdraw, right? So these kind of issues we can face, right? Now what is the conclusion after seeing all this? The conclusion is very simple. So we can have maximum number of consumers is equal to the number of partitions, right? So if the topic has three partitions, so number of consumers in the ideal case we can increase up to three. There is no point to increase the number of more consumers if we have the number of partitions limited, right? So if we are doing that, we are just wasting the resources, sheer wasting of resources. We are not doing anything, or we are not achieving anything. So ideally the number of consumers should be equal to the number of partitions in the best case, right? But usually in the production or in the large scale companies, or it all depends on the business use case. Usually what has happened, so 2 or 3 or 10 partitions can be assigned to one consumer, right? Based on the application load, it all depends on your application behavior, right? So for example, if your topic has 5 partitions, and then what can be the maximum number of consumers? It can be maximum 5 only. If we are spinning more than 5 consumers, then it is just wastage of resources, right? Now let's discuss a few more scenarios. These are very interesting scenarios, and I am sure you would get out of these only 3 to 4 questions you would definitely get in the interview. That is very sure, right? Now let's discuss few more scenarios. Now what has happened? We have topic with 3 partitions, which we have already discussed, right? Now order service has already produced few messages, right? So what few messages? These are the partition keys actually, the 1, 1, 4, these are the partition keys, right? So you can see the message keys as 3, 3. So the message with the order ID 3 is going to the partition 1. The key with the message ID 2 is going to the partition 2, and the key with the message with the partition key 1 and 4 is going to the partition 3, right? So that was all was happening right now. And let's assume these are the consumer, this is the C1 consumer, this is the C2, this is the C3, right? Now as per this diagram, what is happening? So C1 consumer is, what kind of messages it is retrieving? It is retrieving message keys first and 4, right? And what C2 is receiving? C2 is receiving message keys 2, right? And what C3 is receiving? C3 is receiving message keys 3, right? So this is the case as per the diagram. Now what has happened? Now suddenly let's assume the traffic is increased, right? So suddenly traffic is increased on your application, and you can see, okay, now 3 partitions are not enough for your application load, right? Now you can create one more partition. It would be very simple, very alter command is there. I would list down that command also in the description. But let's assume you increase one more partition, right? Now what has happened? Now the topic with the 4 partitions, right? Earlier 3 partitions were there, and the topic with the 4 partitions. Now let's assume you created one more partition, and you have instantiated one more consumer also. Let's assume this is the case, right? Now you would say, okay, my life is sorted now, because what is happening now? Again the same best case, right? The each partition is assigned to each consumer, right? The 4 partitions are there, the 4 consumers are there, right? Now the life is very great. You are thinking that, okay, now my application would survive and all the things are there, right? But no, there is one more problem here, right? What is problem? So I'll just explain you there, which I have shown you in the demo as well, right? Now what has happened, that there is a one problem, that earlier where the message key 4 was going, right? In the partition, the fourth one partition, right? Or the third one partition. This is the fourth partition. I will just highlight this partition with the, this is the new partition which have added, right? The fourth partition, right? But earlier where was the fourth message was going? The message with the key 4, the partition third. But no, after increasing the partition, now let's assume where the message key 4 is going, to the new partition, right? But now let's assume this message 4 is still present in the partition and it has not been processed, right? But this 4, for example, this 4 is the order created event, and this 4 is let's assume the order cancelled event. This could be the case, right? For example, I would just show you here, right? This could be the order cancelled event, right? Because the same order ID, right? Order cancelled event, the order ID is 4, right? And this could be, this message could be the order ID created, right? This could be the message order created, and the same order ID is there, right? Now what would happen in this case? Let's assume what are the challenges we can have in this case. So what would happen, that order cancel might be a chance that it can be consumed first, right? It can be consumed first, and when this consumer would retrieve this message, it will see, okay, that order has been cancelled with the order ID 4. But when it will check, okay, the order has to be cancelled, but when it will check, okay, but this order ID does not exist. How? Because this message, the order created message, has not been processed yet, right? So this is the kind of problem, the out of ordering problem we can have, right? Now this is a very big problem. So now the second question you would ask, okay, why would the message with the key 4 would go into the new partition? Okay, so what is happening actually, Kafka internally, how it calculates the where should the message go, it calculates based on hash key. Now this message order ID is hash key, for example, order ID could be anything. When it creates the hash code, and it would mod the number of partitions. So if your partitions has been changed, right? Now earlier the partitions were 3, now the partitions are 4. It could be a possibility that your key could lie into a different partition, right? So there could be a chances of this, right? Now you would say, okay, now how we can solve this? Now this is a very big problem, how we can solve those. So first of all, we have to be very careful whenever we are changing the number of partitions, right? So we have to be very careful. Now how we can solve this is, first simple thing is, we can design properly at the first place only, right? So at the first place only, if you know that your application is going to have this much load, right? So design your topic partitions at that point of time only, that you would be getting this much application load, and design upfront the topic with the 100 partitions or whatever the number based on your application load. This is the first best use case what you can do. But the second approach is, if the application is not mission critical application, right? Or if you can handle smartly the or you can handle, or you can have a custom logic for handling the out of ordering issues, right? So based on timestamp, you can have the kind of timestamp, and or you can have the very custom logic at your consumer side, or you can accept the ordering issues just for some time, right? So this is the second way. Now the third way is, actually I have seen here, and we have also tried this step 3 in our organization, right? So this step 3 could be, you have to stop the producer. In short, or I'll explain further, but in short, the simple approach is just stop the producer. You have to drain the existing partitions first, and then only start the producer, so that all the partitions get means you have to ensure that the message keys, the new message keys should not, the old message keys should not be coming onto the same partition, right? So the best case is, you can stop the producer, drain the existing partitions first, and then only start the producer, right? But sometimes what happens, it's very hard to take the downtime in this case, right? So the alternative approach could be, which could be beneficial, and we have done this way as well in the production cases. So the alternative approach is, you can create a new topic with the number of partitions, and you can have a custom logic in your application to notify the producer, okay, to send the message on this new topic onwards. For example, okay, you have increased the number of partitions, there could be some kind of automation script which would do all this, right? So in the automation script, you can have some kind of curl command which would hit onto the producer side, and which will notify, actually, now start producing the messages on this topic, not on the old topic, right? So by this means, the producer will send the messages onto the new topic, and consumer would consume the messages from the new topic once they are done with the old messages, right? So this is the best case which can be done, right? So in the similar script, you can notify the consumer also to consume the messages from the new topic only once the old messages are with all once consumer is done with the old messages in the old partitions, right? So that is how we can solve all these problems. Now that was all I was trying to cover in this video. So in the next video, we'll discuss more about offsets, because these are very, very, very important, and this would be asked in the interviews, right? And then we'll do the benchmark performance test, and we'll actually show you how much fast is Kafka, right? I'm not sure whether this all can be covered in one video, or I need to come up with the 2 videos, because I have prepared the benchmark performance test, and I want to show you live, okay, that these are the performance numbers, and what are the factors actually what makes the Kafka fast. So right, so that's all from my side. I can see many of you are watching the videos but not liking, commenting and sharing the video. So please do like, subscribe, comment and share the video. That is the least I can ask. So thanks for watching the video. Thanks a lot. See you next video. Thanks.